Okay, so here's how this little thing called focus and directrix works. We've been doing a lot of graphing with parabolas, okay? Talking about the axis of symmetry, talking about the vertex, talking about whether it opens up or down. But part of what makes a parabola, its symmetry, is something called the focus especially. And what the focus is, basically, is something that tells me it's an equal distance from the focus to the edge of my parabola, and then that same point is the exact same distance to what's called my directrix, which is a horizontal line right underneath, or in some cases, if it opens down, above my parabola. Okay? So knowing the definition of it isn't something that you need to understand, but just kind of being able to see, okay, so basically this point is the same distance between here and here, and I'm not going to make you calculate that, so no worries as far as that goes. But there's always going to be equality. So as I actually get into doing some of these things, this is where all of this equation stuff is going to start coming into play. Now, back to our sheet here, because we notice here, I would hope you'd notice with both of these at least, where the vertex would be. Because whenever we're doing one of these forms, oh, my pen works, there we go. Normally, when we're trying to find a vertex, we're in a form something like this. And then we get our h and our k for our vertex from that. But you're like, but I don't see any of those numbers here. So whenever I don't see them, if I could visually see it in this form every time, this would be what my form would look like right now. And you'll never see it written this way, though. But it's like those zeros we assume are going to be there. So my vertex for this one is going to be at the origin, and it's going to be for 3 as well. If I don't see that plus or minus number after anywhere, there aren't going to be any shifts. So that's one bit of information I can get right away in this case. So I know where one of my dots is going to be.
Can't you just graph it on the calculator?
You can, but you will not be able to get the focus and the directrix off the calculator. So we're trying to get some information this way. So yeah, but as far as graphing, yeah, I absolutely could just bring up a table and get it that way as far as the actual graph goes. So I start to look and I say, okay, this focus and directrix thing, what's going on with this? Well, if I pull my handy dandy formula sheet out, I notice it says when the vertex is at the origin, 0, 0, and they have all this fancy stuff. Well, I want to make life simple. So here's what we're going to do. We're going to take our focus and directrix formula here. I don't like this P idea because we don't actually have P calculated for us right away. You'll notice up here what P equals. That's what I'm going to turn these into, and I'll explain how this is going to make it easier, because some of you are going to say, I don't know if that looks easier. Oh, it's going to be easier. So when we're doing our focus, I want us to think of it as the point 0, 1 over 4a. And we'll talk about where a is coming from in a minute, because it's an easy find. The same thing's going to happen here with my directrix equation. I'm going to have negative 1 over 4a is my directrix. So I'm actually, let's just get rid of these. Let's keep life simple. So you're like, okay, I'm not quite sure where you're going with this, but I'll work along with you here for a minute. And I'm actually going to write them on here too, just so we don't have to flip back and forth. Okay, again, so my focus when I'm doing these is going to be 0, 1 over 4a. And my directrix, which is always a line, it's always a horizontal line, a y equals, is going to be negative 1 over 4a. And you're like, okay, can you explain why you got rid of the p and turned it into this a stuff? Because let's think about the form we're in. We're always going to have access to a. It's going to be the number that's in front of x squared. So if I always am going to have the number in front of x squared, why don't I just want to use that? So when I go to do my focus, it's going to be, when it's at the vertex, we'll talk about when it's not in a minute, is always going to be at 0. 1 over 4, what value is in front of x squared this time? 1. So my a value is 1. And that's what I'm going to plug in for this a for my focus. So my focus is at 0, 1/4. Now,
How'd you get 1/4?
it's just whatever number's in front of x squared. When I don't see a number there, I just assume that it's going to be 1.
Oh, so the slope?
It's like the slope some ways, yeah. It's not exactly slope in these cases because when we're doing parabolas, we're not making lines. But yeah, it's in the same place the slope would be. Now that's a little bit trickier to see. If I were going to graph this, you're like 0, 1/4. Holy cow, Harty. It's like this little tiny dot right here. Those of you watching at home, I don't even know if you can barely see it here. Let's see if I zoom a little more. If we can make this a little bit more visible. Some of you might see that little tiny red speck that's there. Yeah, I was going to say, it's not as important as being able to get it here, but just trust me, it's barely above there. Yeah, my red's not working real well. But that's how I find my focus. I'm just going to do 1 over whatever that a value is going to be. Now my directrix, that's always going to be y equals, because again, it's a horizontal line. That equation is just 1 over 4a. Excuse me, negative 1 over 4a. So you're like, basically it's just going to be the opposite of what this focus number is, and that's true. So it's going to be y equals negative 1/4. That's my directrix. And again, what these are, I'm just going to put a little dotted line in here. Once I draw my parabola here in a minute, what the relationship those two are going to have is, again, they're going to be equidistant from the different points on my parabola. So like if I went to my calculator,
So the directrix and the focus,
Uh-huh.
where do I put the directrix? Is it on the x-axis or the y-axis?
it's always a y equals. It's always going this way. It's always going horizontally. So when it says negative 1/4, like here, this dotted line is just barely below 0.
Okay.
And a lot, yeah, I was going to say, it's going to be really tricky because sometimes it's going to be really, really close to the axis. But again, my bigger focus is going to be, can you calculate them more than am I seeing them on your graph? Because for a lot of times, unless you really, really zoom in, it's really hard to see them sometimes. So then again, when I go to graph, if you want, you can type it in on here, or if you know your base graph, you can do it that way too. Because we always like to see our vertex, which would be at 0, 0 in the middle. And then I'm just going to plot some of my other points.
Oh, you have to plot points now?
Well, I'm still going to draw my graph. Still going to draw my regular graph of y equals x squared, just like I normally would. And if I could get a really close-up look, what I'd be able to tell is that my focus and my directrix line would be equally far away from not only my vertex, but any other point on the line. But for right now, until we get one that's a little bit bigger where we can see it, just keep working with me as far as, okay, just knowing these two formulas and being able to plug in and calculate them. We'll get to the visual part. We will. So you're like, so the only difference really in this next one,
Wait, what do we have calculated?
just y equals and put in x squared.
Oh, okay.
So the next one, now here's the place where it's a little different. What's my a value going to be in number 3? 2. So when I go to calculate my focus and my directrix, okay, it's still going to be at 0 for my x value. But when I do 1 over 4a this time, I replace my a with 2 because that was the value that's in front of x squared. So my focus this time would be at 0, 1/8, which again to the naked eye is going to be negligible. It's going to be so close to these we're not going to know. But again, my idea right now is just to be able to calculate them. Okay, that's our biggest deal here. So 0, 1/8. So like, okay, so then my directrix is going to be y equals negative 1/4a, or negative 1/8 with my y equals. And you might start to notice, especially with these ones that are at the vertex's center being the origin, you're like, so it's just basically positive, negative is what's starting to happen with a lot of these. And it's true. It is. And then again, when I go to graph, what we're going to do, yeah, the formula for these is 4 over a, 4 over a. Yeah, I don't get to pick which number I want to use, if that's what you're...
No, I mean, like, on our sheet it says a equals 1 over 4b or b.
Right, but as I was talking about a bit when we were back over here, if you try to use p, you're going to have to go back and substitute this stuff in anyway. So I'm just having you change it into the a form since a is readily available from your equation to make it a little bit easier. So when we come back, and I'm glad you guys are asking questions, that makes things better now, and it also makes it better for people watching later. So here, I'll get my 2x squared up. And again, I could do this with a chart. We did that before, but since we have access to the calculator, we'll just go ahead and use it. And again, since my vertex is at 0, 0, I'm just going to go ahead and plot the points that will fit on my graph. But if I didn't have a calculator, I could just plug in 1 or negative 1 for x. And I just would end up with a chart, just like the one you see on the screen right now with the graphing calculator, and get the same thing. But again, biggest thing, graph the parabola, calculate the focus and the directrix, because again, with the numbers being this small, it's a little bit tricky to see them sometimes. So that I'm not as concerned about right away. Okay, other issues so far, because like I said, the questions you've had so far have been really, really good. Like, no, as long as something doesn't change too much, it might be all right here. Okay, let's flip over. We got one more here that's staying at the origin, and then we're going to start moving a little bit, so the formula is going to change a little. So when we get to the back, we go, okay, our vertex is still at 0, 0. I don't see any pluses or minuses anywhere. What's my a value going to be on this one? 1/3. Oh, the dreaded fraction. So again, when I'm going to figure this out, my focus is 0. This is where the fun's going to begin. Now, here's where I want you to think carefully, and I'm going to show a little side work here so you can see what I'm doing. I can get to it on the calculator, and I'll show you, but I want you to understand the number sense of this, okay? So when I'm doing this, do this on a sticky note off to the side here. So if I looked at that, I'm like, okay, 4 times 1/3, 4 times 1 would be 4 divided by 3. So right now, you're like, ooh, I have a fraction over a fraction. I'm not leaving it that way. Whenever you have a fraction over a fraction, all you have to do is take the reciprocal of this, and it becomes what it will be. This is going to become 3/4. You're like, well, how does that happen? Because here's how I want you to think about it. If you think about it as far as dividing with fractions goes, okay, so if I were to do 1 divided by 4/3, our rules of fractions tell us when you divide by a fraction, it's like multiplying by its reciprocal. So what I would do is I'd flip this fraction over, and it becomes a multiplication problem. 1 times 3 is 3. 1 times 4 is 4. That's where this, okay, which is my focus, comes from. You're like, well, could I do that on the calculator if I wasn't sure? Because I see what you're doing, but I'm not sure I'm going to remember that. Sure, we can do it that way too. So if I want to do it in the calculator, here's the thing I got to be careful of though. 1 divided by, your fraction would have to be in parentheses. It has to be. Now, when I first hit enter, you're going to be like, ugh. Math, enter, enter. Okay? So if the whole idea of trying to figure this out on your own drives you crazy, you can even take it a step further if you wanted to. You could do 4 times 1/3. You could do what the denominator says. And then do 1 divided by the answer we just got. Math, enter, enter. They all work. But again, I want you to understand the number sense of it. So I'm not getting tests and things coming in later that it's 1 over 4/3 because I won't mark it right. We've got to be able to simplify those things, okay? So my focus is 0 3/4. Just like we did when we did our side work over here on the side. It's kind of a good place for the side work over on the side. And then once I get that, I have a pretty good clue on what my directrix is going to be. Because remember, when we're doing the directrix, that's y equals -1 over 4a. And we just got done figuring out what this all is. It's 3/4, but the negative's out front. So there is a direct relationship between the focus and the directrix. They're always going to be the same distance away from my vertex. This is 3/4 away from 0. This is also 3/4 away from 0, even though it's a negative. So I've got my vertex. And again, if I want to go to the calculator, there's nothing wrong with that.
Are they always the same?
There can be a slight switch depending on when my vertex moves, which is what going to be the next one we do. So here, and we've always talked about we like getting values that aren't decimal or fractionally. So here what I actually do is I'm just going to use the 3 and the -3. Because that'll actually give me a more accurate graph. And if I wanted to see the focus and the directrix this time, I think I'm actually going to be able to see it this time. 0 3/4 would be just below 1, so it would just be this little dot up here. And my directrix would be, again, a horizontal line that's going to be equidistant to my vertex and some of the other points. But again, my main focus is that you're calculating them, not that I'm seeing them necessarily on the graph, even though it kind of lets us see where they come from. So again, it's not too bad just once you get that formula. Now, here's where life gets a little more interesting. 5's in vertex form. It's not going to be at 0, 0 this time. What's my vertex going to be on number 5? -1, -1. Well done. Now, since it's not at the origin anymore, how I calculate it's going to be different. So I'm going to go back to my formula sheet here. And I'm going to look on the back, because the ones on the back are already changed over for us, unlike the ones on the front. So when they're in vertex form, this is where I want to be. And here's my focus and my directrix formulas that I'm going to use when we're not at the origin, when we start having shifts moving around. And again, you're going to have this at your side with the homework, the quizzes, the tests, everything, but you want to get used to using it, okay? Because we already are going to have our A, and you're like, what's this K thing? Oh yeah, it's just my Y value from my vertex, okay? So when we get doing these, so again, keep this out handy. I'm going to look at this and I'm going to go, okay, I want to do my focus first. So I look at my formula here and I say, okay, my vertex is -1, -1, which is my H and K values. So when I look at this and it says my focus is H, K plus 1/4A, oops, it would help if I was on the screen. There we go. What I'm going to do is I'm saying, okay, so H is -1, my K is -1 plus 1/4. What's my A value? What's in front of my just, well, and if there's nothing, we assume it's going to be 1. You're like, whew, check all that out. So I'm like, okay, I'm just going to do a little simplifying and I'm going to be set. So -1, 1/4 times 1 is 1/4. So let's see, I want -1 plus 1/4. Nicely done. So this, keep moving, Harty, is -1 plus 1/4, which is -3/4. And that's where my focus is going to be. So I got to do a little bit of playing around with this, but I can even play with that in the calculator if I really wanted to. So then I look and I go, okay, so is the directrix going to be something similar again? Well, let's see here. So then with my directrix, it's y equals k minus 1/4a. So -1 minus, oh yeah, 1/4 times 1. So this time, it's -1 minus 1/4. And again, can I do this in the calculator? Sure, you can do this part on any calculator. If I was going to go and do this, I just, again, -1 minus whatever you do for fractions, put them in parentheses. And I'm not really cool, well, I'm not going to scream and yell if you do the decimal, but I'd rather do the fraction. Or you can put -1 and 1/4, or if you put -1.25. Like I said, I'm not going to scream and jump up and down and yell. But when you see it, especially as the mixed number, it makes more sense because you're like, if my vertex is at -1, -3/4 is 1/4 away. -1, -1 and 1/4 is 1/4 away. And then again, for the rest of it, especially since I know the vertex already, I don't worry a whole lot about the rest. I'm just going to type this in. Bring up my chart. Now again, I know now that since my vertex is at -1, 1, I've got to make sure my -1 is in the middle of my chart, because then I'm going to see the symmetry that's involved. And I'm going to be able to plug those in. And again, as many as I can fit gives me a more accurate graph. And these are going to be tight again where I'm not going to really be able to see them real well. But again, I did my calculating over on the side, and I let the calculator help me figure out the other part. Now, I want to do one more with this funky stuff, and then I want to show you one other thing. So let me shrink that down. I want to look at number 6, Because at first, it may seem like it's back like the first ones, but it's not. Because here, my vertex is going to move a little bit. What direction are we moving with that -1? Okay, it's like a down 1, which means my vertex would be at 0, -1. Or if you look at it like the form, so if I'm looking at my standard form, that -1 is this plus k. Okay. There's nothing in parentheses, so my h value would be 0, but my -1 out here is where this is coming from. Okay, so I know I got a point. I know it's opening down because it's a -x². And for the rest of this, I'm just going to do what I did on the last one. So my focus is my h value, and then k plus 1 over 4. What's my a value this time? -1, because it's a negative in front of my x². So I'm like, okay, so 0, -1, and this will be -1/4. So -1 minus 1/4 basically. And again, if you have -1.25, -5/4, I'm happy with all of those. I'm absolutely content. Keep life simple. But that would be my focus. And again, as long as I have my values, it shouldn't be that hard to come up with them. My directrix, again, is k minus 1 over 4a, which would end up, if this is -1/4 and I'm minusing it, ends up being plus, because that's what minusing a negative is. So -1 plus 1/4 is -3/4, or -0.75. And again, our main focus here is just to calculate those, because again, when it comes to graphing, I can always punch that back in here or use a table. And the nice thing about this is we're always going to have our vertex ready. We just got to get it centered up to see the symmetry. So I'm like, okay, 0, -1. We're at 2 on both of these. And we're at 5 on both of these. And I draw that in and I'm good. Because did I just bonehead something? Let's find out. I did. What did I do? Let's find out what I did. Oh, I see what I did. I didn't pay attention to the negatives. Bad Harty. Bad Harty. Oh, boo. This is why I should use pencil. Thank you for the heads up on that. I even mentioned that it was going to be opening down, and I still wasn't paying close enough attention to make sure that it opened down. Bad me, bad me, bad me. So that's going to open down for me. So there's one last thing. Okay, we've got use the information provided to write the vertex form of the equation. Now we wrote that up top, but we will write it in here again. So you're like, okay, so I need to know A, I need to know H, I need to know K. These are the three values that I have to know to be able to make this form, okay, make this equation. The nice thing is, when they give me the vertex, they're already giving me H and K. I got 2 of the 3 already, but I don't know what A is, okay? But here's what can help me. Vertex is at the origin, and I've got the focus. So we remember the focus is 0, 1 over 4a. So rolling back there. So I look at this and I say, well, if these are both 0, then negative 1/4 has to equal whatever 1 over 4a is. They have to be equivalent. These have to be the same thing. So then it's just a quick proportion. Cross multiply and solve it. So negative 1 times 4a would be negative 4a. 4 times 1 is 4, and you're absolutely right. My a is going to be negative 1. I already have my h and k. So I'm like, okay, so y equals a x minus h squared plus k. Now, if you write it that way and leave it, it's fine. I'm not going to tell you it's wrong. But like I said before, most of the time we don't see the zeros. So most of the time, that's the way that you'd end up seeing it written. But I am perfectly happy with either of those. And I want to do both of the focus ones first so we can make sure we're kind of seeing how this works. But your whole job every time on these, you're going to be like, okay, now the vertex moved this time. It's still my h and my k. But my focus is still going to have the same relationship. So here, my focus, because remember, when the vertex moves, here's what my focus formula is. Okay, so I'm going to actually write that down here. So it'd be h k plus 1 over 4a. You're like, uh-oh. So you're telling me these two things have to be the same? Yes. So this could get a little more interesting. So negative 15/4 equals negative 4 plus 1 over 4a. Ooh. How's this work?
How'd you get that plus negative?
Because again, this is my formula when my focus, and it's not at the origin, and this isn't. So that's the form that I'm using. So I'm just working it and just plugging the numbers in that I know. So here's what I would do. Negative 4, I'm going to kind of forget about this guy for just a second. I want to turn negative 4 into fourths. Now, or I could, oh, I can't believe I'm going to do this. It kills me to do this, but I'm going to do it anyway. Or I could, if I was trying to solve for x and I wanted to add the 4 over, here's basically what I'm going to do. I'm going to add the 4 to both sides. Oh, I don't want to do this, but I'm going to because I want us to keep life simple. So negative 15/4 plus 4. But what I do need you to do for me is keep it as a fraction. Some of you can do that without going to the calculator. But again, I want to make it where it's workable for everybody. Once I get that out, I've isolated my a term. Now I'm just going to cross multiply like I was doing before. So 4 equals 4a. So my a value is going to be 1. So I just say, okay, so I'm going to rewrite this. Y equals a x minus h squared, and then plus k, but it's a minus, so I'll just use the negative. Your whole job is going to be finding that a. Gotta find the a, gotta find the a, gotta find the a. So you're like, okay, so am I still finding the a even when they give me the directrix? Yes. Whether that vertex is at the origin or somewhere else, again, if it's at the origin, you keep on the front side of the formula sheet. Y is negative 1 over 4a. Okay. So if y equals negative 1 over 4a, and I already know that's my directrix, all I've got to do negative 1 over 12 equals negative 1 over 4a. Do a little cross multiply work here. Negative 4a is negative 12. And divide both sides by negative 4. So my a value is 3. And then like we said before, I can plug it into, this form and put zeros in the other places. Again, I have no issue with that. Or if you're like, oh, the zeros aren't really there, so I'm just going to write it without them. But either way, we're good. And then the last one, again, just shifts my vertex. So I've already got my h and my k. And I know that this has to equal negative 1 over 4a. So negative 1 over 4a equals negative 7 over 8. And yes, we even can get fractions on these. So negative 28a equals negative 8. And if I divide by the negative 28 and do math enter because decimals not as big of a fan of here, would be 2/7. So let's see here. Now you're like, Harty, wait a minute. Harty, what did you do? They're like, Harty, you didn't. Oh, I did. Is this one at the origin? Is my vertex at the origin? No. What side do I need to be looking at?
On the back.
Is that formula different?
Yeah.
You're like, Harty. Ooh. So, you're like, crap. This is where I like having sticky notes. Those are the little things, though. Even though you have a formula sheet, you've got to make sure that you're being cautious of. So you look at the directrix on the back and you say, okay, it's negative 7/8. But the formula is k minus 1 over 4a. You're like, oh, here's this thing. I need the common denominator and all that stuff again. Yep, we're running down that road. So I'm going to add the 1. To save you time, I'll do the work for you, but you could do this on a calculator or by finding a common denominator. It's going to be 1/8. And then I can actually finish this off just with my cross multiply. And divide. So a equals negative 2. So I go, okay, so y equals negative 2 x minus h squared plus k. So, your job is to tackle this guy, identify the vertex, focus, and directrix, and sketch the graph, just like we were doing on here. And then there's some problems on the back that have you working with these and putting them into formula form. Now, I'm going to say what I always say. Even if it's not a complete finish of this when you walk in tomorrow, you need to have tried at least 1 or 2 from each of the sections. It's not like it's a monstrous assignment at 12 questions, but even if you've done 3 or 4, if you don't reinforce it tonight, you're going to forget it. And this isn't one of the sections we're going to spend 2 or 3 days on, because tomorrow we're going to be hitting up a little bit with the factoring too. So you've got to be ready to roll with this. So check this out later, come and ask a question.